Right, I've been to the loft and got the last 2 drives. I thought I had several drives, I don't know, unless they got separated, I can't find them. I suspect they've come out one by one to fix various machines that have been sold on in the past. You can see this one here was fixed 2019, but, well, it's suffered an ouchie here in storage. So, yeah, I'm just going to put the pliers in here and just try and manipulate that somewhat straighter. You can argue take it off, I might do that anyway in a minute. But I'm going to need to do that to clean it. Let's just bend it over further than it needs to go and then try and flatten it. Oh, that is a bit bashed, isn't it? Yeah, I think I'll take that off. Let's just try and unclip that. It's one of these ones, is it Panasonic? It's TEC. Yeah, it's one of the ones that have got a clip over there. Hang on, I'll try to get under it. And it's got this clip on the bottom, look. Is that screwed on? No, it's got one of these things on the bottom. So you've got to take that off in order to get this off. Just because it overhangs just fractionally. Can't remember what I did to that drive. Obviously the button's not on it at the moment. It had fallen off. But, well, it just gives us a bit better access to try and straighten this somewhat further. Yeah, it's had a really nasty dink on the corner, that. It needs sort of bending outwards. Like that, just marginally. It's a bit straighter there, but it's really bad in this corner. In any case, if we just crimp a little bit around that general area. Yeah, it's only aluminium, so it's straightened out fairly well there. Right, I'm going to get that back on. I'm going to just I could take it back off after just to clean the heads, but I mean it was inside like an ASD bag in the loft. That bit there and goes up this side, doesn't it, I think? Yeah, and then the screw holes all marry up. So what was that from? Maybe 1200, I'm guessing. So I've got the button here. It's not got any plastic notches on the bottom as it's supposed to. No, that still looks in one piece. I think I just detached it in order that would not get smashed off. And yeah, there you go. I just put it inside the drive, but yeah, that will work. So this might be the test drive I end up keeping, because I need another drive to replace the one that I spent God knows how many hours fixing. There'll be a link top right to that. And that went into the GBA 1000. But I've also got this one, and this has got a nasty dent on it as well, look, in the same box. Something heavy must have fell onto these at some point in order to do that. It's one of these ones where you've got the little screws in the corner, so we'll just get those out. This one's a JU-253, again, previously fixed. I think it was covered on my channel. I fixed several of these before I even started doing my channel. Around the time I got from my 500 and 1200. I just went through a phase of buying loads of floppy drives dead cheap for like $2.99 or something, shipped off eBay. It must have cost, that much for postage. I think in some of the cases it was more than the actual cost of postage. So yeah, it looks pretty good inside, doesn't it? It looks immaculate. But the issue with this one, and I think I've shown this one before, this one I think came from Stefan. Thank you very much for that, Stefan. And it's got a sensor missing here. It should protrude here. Yeah, the disc change and write protect, I think it's 2 things in one. So what am I going to do with that? I don't know. This would be a good candidate to fit into the 500 plus, I think, if I can find some solution to that. So let me just have a look what drives I've got spare. Yeah, it's very likely I'm not going to have another JU-253. This one's got no heads, parts only. We've got switches there, look. But you see, they're not on a PCB. This would have had a little PCB that sat in this corner. So, like, could I adapt to that? Probably not. Not without making some little PCB, jerry-rigging something up. And then we've got one here, again, was sent from a subscriber. I can't honestly remember. This one, it says failed ICs. This is one of these ones where, and it says they're 1200, 2000, 4000, etc. And you've got the jumpers there, or what it's set to. I think it was a modified Sony. This has got a nice little round LED. That's cool, isn't it? But this is dead. This has a fault. But again, well, has it got? Yeah, it's got some switches in there, but they're probably soldered on some other PCB. I don't know, maybe I can cut the PCB up on that one. This one came from Plan C. I had a quick look at this when this arrived, so I might recover this in a minute. Again, it's got the switches here, but they're on the main PCB, they're not on the PCB of their own. So, I don't know, I'm going to put these other ones to the side for the moment, and we'll start with the one that we know does work. I'll just get that 253 back together. And before I stick that lid back on, there's two things. That bracket there's a bit bent, presumed from when someone's obviously been in it in the past. I won't have just done that because, well, that's really bent. That's it. And this little dimple here, well, what you've got to do is counter dimple it. So best way is under magnification. You want to get a sharp implement and put it dead on the centre of the point there, and then press down fairly hard, maybe even hammer. You could also use the flat end of a screwdriver like that. Again, hammering is better. Got that out somewhat. It's probably pushed through further than it was before, to be fair. Yeah, I actually think I've done the inverse now. Now it's protruding out a little bit. Yeah, you want a flat surface really, something hard underneath it, something solid rather than a mat. So I think what I'm going to do is put it on this table, put that underneath it, there, just so that this takes the brunt of the actual impact, and just do a bit of tap like that. Yeah, it's fairly well flattened out that now. You could do the inverse, try and, I don't know, it's quite hard trying to find something to stick it on where it overlaps, you know. You want it somewhere like that, but on a corner so that this doesn't stick out. And then just do a bit of like this. It's just metal work. This is the sort of thing people do when they try to move dents from cars. Yeah, somewhat flatter. And needs another dent, another bang down that way now. A bit of alternating from side to side though, you can probably get that out completely. That's not bad, it's better than it was. You can tell something's happened there though. Yeah, it's easy to get these around the wrong way, because you can see a one there, it means that is the one for that, and the one for this is over here. That's not going on very well, that's it. And I've got 3 of these as well, strangely enough. I don't know where I accumulate all these things from. That's keyed, so you can't get that wrong. Do check that if it's not keyed, because you'll burn the drive out, as I did. And then we're going to connect this up. Try and work out where pin 1 is there now. It's keyed that, isn't it? So it can only go that way. So you've got to hope the key is correct there. Let's give that a try. I'm just going to put the drive there, I think. Careful to not short anything. Let's put it in that corner. Connects up video and power. Let's just see if it'll auto boot. It's not got a switch, that drive, so it's automatic. You know, it's soldered to just short the contacts so that it thinks there's a disc in the drive all the time. But of course that'll be a problem if you ever change the disc, because it won't recognise you've changed the disc, and of course the write protector is an issue too. Anyway, let's connect that up. I'm going to get my June test disc. Before I stick the disc in, I am going to actually just make sure it boots okay. Yeah, that's booting. So the cable was the right way round. It's just that there was no disc in the drive and it's silent for quite some time. But anyway, that is booting up. Can I just put that drive down somewhere? It might not read as well when I'm knocking it around like that. See what happens. I think that's working right there. Try and move these screws out of the way. Yeah, so at a pinch, if I could deal with the sensors at the front, I could fit that in here, and it's quite a nice candidate because it's got these little standoffs here, which is what you need to marry up there. I've got 3 screws to go there, just a screw to screw into the side there, and I think, yeah, this has got the points at the front there to screw it in at the front. So I think that should be alright. Right, let me test that other disk drive. I'll let this one go through a little bit. I'll just watch the demo here, and then I'll wire up this drive and we'll see, does this one work? Because as I said earlier, right now I don't have any test floppy drives for Amiga stuff, and it's been causing me 1 or 2 issues. Right, I'd say I've had some personal traumas today. My wife's away at the moment, and well, I can't go into it. It's just so many problems. Just yet another trauma in my life that I just don't need. So I'm trying to de-stress, and the way I'm doing that is by looking at these drives. So this is the one that definitely works, everything is there. This is the one without the switch where the solder blob, I can't even see it now, it's there, blob, soldered. We need to mount something here, and this is why I've got this one to pieces, to compare the height, so I can work out where these two switches are right next to each other, so we can use the same assembly for both. Now there's a hole here, isn't there? Yeah. So if I cut a piece of PCB or Vero or something and get it in there first of all, so it's the right size to fit in that channel, and screw it in, and then I'm now going to take the sensor off this one, 3 contacts again, and try and mount it on some kind of PCB. That's the thing, I don't know what I'm doing, I haven't got a clue. Some sort of PCB, and just see where we are really. Measure this up against a PCB, see how high it sits up, and then join up with 3 wires. It would have been wires originally, I think, on the original one, or a flex ribbon or something. Right, let's try that again. Thank God my wife's alright now, everything's alright. It was yet another one of these days where I was, and this is the thing, don't take this the wrong way, it reflects the psychology of my state of mind for the last few years. Thinking I'm in hell, thinking I've died and gone to hell, thinking about that Neo Geo, you know, hell is deep, Chris, voiceover shit. That's what it sounded like. I think that's just my interpretation of it, although a few people did say it sounded like that. But I kid you not, we've just had that many bad things happen. I mean, I can't go into some of them because they're very personal, but you wouldn't believe how much bad luck we've had with so many different things. A lot of things, like crazy, scary amount of things. And I thought it was another one of those. My wife, just phones, here's an example, just phones. There'll be some phone repairs coming up on the channel. My wife's been for about 4, maybe 5 phones in about 3 years. It's a regular expenditure. I almost feel like sticking it in the budget. When are we going to get this new phone in the next 6 months, or is it 12 months? We've had that many phone breakages, and I'm not talking about drops, I'm talking about like just suddenly packed in, batteries gone, you know, screen mysteriously cracked even though it's in a carry case, never been dropped, knocked, banged, won't charge, moisture detected, not been near any water. And then the one today, phone just wouldn't power on. It just mysteriously it was working, 100% charged, filming something, 30 seconds later, screen's black, won't power on, won't do anything. I mean, there's a lot to be said about Samsung phones, and they're all Samsung ones. But I'll tell you what, my Samsung phone, I'll show you, it's here. I've had this since 2019, when we both changed our phones at the same time. The case is obviously really horrible and battered up, and the plastic protector's got cracks on it, but the screen's perfect. So this has been dropped about 400 times. 400 times since like 2019. I've dropped it on concrete outside, it's been dropped everywhere in its protector, and it's still solid. The only thing with my phone is it doesn't charge anymore. The USB, you've got to like hold your tongue at the right angle, and God, that's not coming off, is it? It's like well and truly welded on there though. Yeah, anyway, so I expect some phone repairs because, well, I need to fix the 3 or so that I've got. I think a few of them are sold and they sell for like 20 quid, but they'll cost you, at the time they costed about £150 to replace, so I'm like, I regretted selling the first ones, which is why I've got 2 or 3 sat on the side waiting for me to have a go at trying to get inside them. And I'm sure it's going to be traumatic doing that. I'm just trying to bend these up. There's no other way I can get that off, I don't think. Oh, it's really difficult to see what I'm doing here. I might have to get Kavanos cam onto this. One contact's up. It's just these other ones now. And it's just like, it's not coming off. It makes me think it's soldered on both sides, you know. Like maybe there are 3 solder contacts on the other side of this PCB. I'll report back in a minute. Yeah, CavCam to the rescue. I want to give a special thanks to anybody that's given me a donation recently, and over the last 3 or 4 years actually, on coffee, because, well, it doesn't get a mention, and it should do. So, yeah, I'll stick some names up here, just to say thank you to the people that have donated in the past on the coffee, because SLR Mod Shop, not Ship, it gave me an amazing donation yesterday, which, well, it's just come at an amazing time. It's just really helping me out with parts and things. Oh my God, I can't get onto that. It's quite hard doing it under magnification. There we go, it's coming off, I think. Now, it's in a small cavity there, so you know what, this is the thing. Again, it's like, it's really hard to get off there. And it's slotted on. You know, the plastic, you can see here, it slides onto the PCB. So, I don't know, I'm going to have to take this board out, aren't I? We've got a screw there, don't undo that one, because that's the sensor for the RPM, I think. It might be like the CPC, where you've got two things. You've got track 0 sensor, and then you've got something that detects the initial part of that track, like sector 0. But it's probably for RPM, that. But if I just undo that like that, maybe, hang on, I was going to say maybe this PCB will lift up. I was thinking this is going to be on it, but this is over it, isn't it? So like, this isn't going to lift. Oh my god, how'd you do that? I don't want to have to take the whole thing to pieces to get this out. This is quite possibly the most frustrating thing ever. This drive is balked, yeah, it's not got heads, yeah, or it's got one head there. I don't think it has actually. Yeah, it has, it's got one top head, but that head's probably balked. I've took the tray out, it was just barely hanging in there, so, you know, these are the sorts of things that, well, it's mostly getting on the bin. But how do you get this PCB out? The thing here, you can slide it, look, yeah, but you can't clear the chassis. You can't clear the chassis at all. So the only thing I can think is try and remove these two screws here, and then maybe, just maybe, the motor will release, which will mean the motor and the PCB, but you see this is stuck on, so I don't know what's going to happen here. Oh, it's come down, there we go. This is where, if I want to protect these flex ribbons, now is a good time to disconnect. Yeah, now is a good time to try and disconnect that, like that. But I think this is going to go in the bin afterwards, actually. I think I might just keep the PCB separate because of that chip and that chip, but the chip here was balked. Everything about this is balked, really. Anyway, now we can get that off, I think. Phew. Now, it did cross my mind that I could have used a Dremel here, or saw or something, and cut this here, and stick this into that other drive. I don't know. But it's going to be joined with wires anyway, so I think, you know what, a DIY PCB to attach this into the other drive is going to be fine. But this is going to be some real MacGyver stuff here. It really is. Which one's that? That's the other drive. It's not that drive we're hacking. It's this one. Yeah, so it's got to be some sort of MacGyver-like fix in order to pull this off. Now this is going to be the tricky bit, isn't it? See, look, ideally you'd think, oh, I'll stick it there. Well, you can't, because it's outside the, you know, it's not in the right place. It's like, this needs to be in this gap here, like this. I think that might do it if there was some way of securing that to a PCB and screwing it on here. Right, there we go. So it's got to be right forward with the contacts, hang on, facing out here, yeah? But you can see the screw point here is right next to it. So what I'm going to have to do is have a slightly L-shaped PCB. Right, I am flying by the seat of my pants here. I've just thought of something that I think, because we've got a hole here, I'm going to try and get like a small screw, maybe even a bolt, a nut and bolt, and I'm going to cut a hole there, grind a hole in this somewhere so that it fits over that little metal nut. That'll key it. I'd say the other thing I could do, I've just thought of as well, is if I had this in just the right place, so that was wider, I could cut out a channel here, and it would hold the back end of it. Yes, I've put a much bigger bit on. It's one of these things I wish I'd never started here. High speed. A Dremel might be better than this, because it's getting caught really easy. You can see it's just hardly doing anything. Yeah, cranked up to larger bit. It's painful, this. Right, that's taken about an hour. I've got dust everywhere, including in the switch. I need to clean it. I need to clean everything. If I just move the microscope over, I'll show you what I've done. So you can see here, I've got a little hole. Should be big enough for a screw. I might need to widen it, and it's going to be very close to the very edges there. But I might be able to get something there. And I've got a little notch here that corresponds with that thing. And then the switch, you can see, is in the sort of right position there. Now, if I get a disc into the drive, just carefully here, and if you watch the switch, see, it's over the top of the right protect thing. And then the other one is just under here. So it's like it's detected the disc's in. So you know what, that's going to work. It's just a case of trying to secure it. And you know what, after messing around with this for a while, you know, 3 or 4 different pieces of PCB designed to fit in there and under here, to raise it up, to attach there, to screw in there, it just dawned on me, I'm better off just sticking a double-sided pad, sticky, you know, foam pad that's a couple of millimetres thick. I've got some of that stuff. Stick it down, have the wires on, and just join it up, because this is going to be a test drive. And I suspect it's going to be reliable for me testing. I'm not that bothered about it being super reliable, am I? Here we go. I've been playing Left 4 Dead 2 on my the Xbox that was donated from Ian Scott Johnston, and on the one from Palmer. I've been playing a fair bit of Left 4 Dead 2. Right, let's now power it on, I think. It's on. You see, it made a noise there, making me think it thinks there's a disc in now. Like, how does it think there's a disc in now? I think that's the disc change one, isn't it? Because you heard it click then, watch. Oh, it's not. It's that one. Yeah, it's going up and down. So these two are the wrong way around. So, yeah, I'm quite confused. I think I need to check this. I think this is a normally closed switch, and it needs to be closed rather than opened. So you see what I mean? It's like now it's closed. If I press it, hang on, now it's open rather, hang on. If I press it down, it doesn't do anything. Yeah? So the screen is still showing the kickstart screen. You know? So it's still showing the sticker disking screen. As soon as I release that, then it detects a change and the screen changes. Yeah, I'll show you that there. So like, I'm not pressing anything here, right? I'm pressing it down. The drive makes a clicking noise, but it's not doing anything. And as I release the switch, not pressing it, it's detected a change. Which tells me the logic here is the opposite way around. That is such a pain. It's like, why did different drive manufacturers do that? I mean, obviously, you know, it's a consequence of the type of switch they selected, and I don't know, it's like really irritating, because it means we can't use this without some sort of modification here. Right, so good job I didn't spend any more time messing with that. This is normally closed. In other words, when the switches go like that, they go open. The centre pin is ground, which is what I've confirmed here. If you measure from the ground of the chassis to the middle pin, which is marked pin 3, then you get a beep. So that's really annoying. Because this is a test drive, I think I'm going to stick a toggle switch on it just for the disc change. The right protect I'm not that bothered about, it's just for test purposes. So yeah, I think somewhere on the chassis here, I'm just going to find somewhere, try and bodge a slide switch. Yes, I am just bodging a toggle switch on the side. It's like a momentary. I'm sticking it on the, you know, the side where you flip it and then it closes the contacts. I think I might need to change this in a minute if it's not right. Yeah, and I am going to take that down. Right, so I'll wipe the top of this before I stick this down with something. I'm going to stick it on the front like that, I think. Yeah, aluminium foil is just not going to cut it, I don't think. So I'm going to step up to duct tape. There we go, that'll do me for testing. I christen the Ghetto drive. So there is another fault with this. It's intermittent when you first switch it on. In fact, it's not intermittent, it just doesn't work. And it warms up over a minute and then it starts to work. I noticed this over a few different days of testing with the bodgy switch on the top there. So yeah, I swapped out a little electrolytic there. It was bipolar, 1 microfarad. I've put a ceramic there. Yeah, that's me being bad. This is just going to be a test drive. So I heated with hot air when it's cold around these things. Didn't seem to make a difference. Here, did. There's a little cap under there. I think it's the main cap for the 12 or 5 volt rail. It might even be a tantalum actually looking at that. So anyway, what I'm going to do is unscrew the board here. Just flip this up and have a look. That's it. Yeah, sometimes incredible force is all you need. Might need to detach the heads probably. Yeah, I think we'll need to just carefully. Hang on, we can. Oh, yeah, we can. We can pull that out. Pull the head connection out there. Just that. There's these motor ones down here as well. Well, they're hard to get to. And the red one. Wow, that was difficult. And then we've obviously got this connector here, but I'm not too worried about that. I'm more interested in trying to, there we go, just get that over like that. Yeah, look. Don't know what that is there. I think that might be a tantalum. It's interesting how heating there seems to solve it. Oh, but there's liquid. There's goo here. Something there's leaked. That cap, I'm guessing. That's the first time I would have seen something like that leak. Let's just disconnect this. I can move the drive out of the way. Yeah, can you see? Can you see the light here? There's goo on the PCB around that mount there, look. Right, let me have a bit of an inspection. Right, after that power cut interruption. Yep, we've had a few power cuts here. I'm going to try and remove that. It's definitely on a power connections from the drive. I'm guessing over the 12 volts. Let's just try and heat this point here. Very small solder points on this. Oh my god, that's hard to get out. That's it. It's definitely that. That's all gooey. I don't know. I mean, look at that. Make it out what you will. I don't know. There's not a mark on it. It's got lumps all over it. It's totally irregular in shape. That is weird. That is really, really weird. And it is all oily. There. I don't know what it was now. Where was it? Yeah, and where it was here, you can see all the discoloration. So anyway, I'm going to clean up around that with cardboard and do some connectivity tests. I'm guessing it's just a cap, some weird hybrid type, like a liquid tantalum or something, I don't know. Yeah, there you go, it's come off there, look. All that goo has gone. Brown here, brown's 5 volts from memory. So it's going between 5 volts and something. And there's something I was kind of expecting to be ground, but it's not going straight to the ground. The interesting thing is, it says here L6. I'm thinking maybe there's nothing wrong with that, you know. It's just a choke, isn't it? That's all that is. It's not a mysterious cap. That's just a choke. That's just like an inductor. So I'm going to stick that back on. I think there was something on the board that's leaked from somewhere else, actually. I mean, maybe that was the issue. Yeah, it's really fluxy. There's like something all around this connector here. It could be flux that's gone weird. So I'm going to get this back on. I'm going to toothbrush. You can't get this around the wrong way. It's just, you know, a piece of wire, basically. So I'll solder that back in place. And I'll toothbrush around it. I'm just going to reassemble it and retest it. I could be barking up the wrong tree here. Maybe it is just one of the other caps that's on the other PCB, not this. I feel relieved though that we haven't got some sort of mysterious component there now. Now it does make sense to me as to what it is. It doesn't make sense as to what the mysterious liquid is around that area though, so... Yeah, anyway, just to be on the safe side, as I say, I'm going to toothbrush around the top and the bottom side of that now. Because you know what, whatever stuff that was could be the issue. And of course it could be electrolyte from something else. Maybe something else was stored on top of that drive and has got onto this part of the PCB here, gone through the screw hole. We don't really know, do we? Because, well, this was sent to me 4 or so years back with a load of stuff. Yes, it had the switches missing, but we don't know the history. I'm going to clean the wider area on that board. Let's just clean the whole thing. Why not? Just in case something has got onto it. And you know, electrolyte having leaked onto a board like that, that's the sort of problem it can cause, intermittency. I mean, obviously it can corrode, but sometimes with things like that, you get like a time-based thing where, you know, it as it was here, not working for a period of time, and it warms up and then it's alright. What happens is charge balances and things, you know, and resistance changes. Yeah, there's no other electrolytics on that. So I mean, that is not what I expected at all, for a few reasons. First of all, I thought that there was a cap and it isn't, and then secondly, I thought there was a cap on here causing the issue and clearly there isn't. I'm sure the original fault's going to come back. Switch it on. Right, let's get test kit back in. I need to do the disc change, don't I? Booting straight away this time. Maybe it was that goo. Because, alright, we heated around that inductor, but I mean, it worked the first time there. It wouldn't usually do this when it's been cold. And I think that drive is cold. Mind you, I did heat these with hot air, didn't I? Let's have a look at here. Because the other telltale sign when it's cold, when you do calibration, it comes to 1111 here, and then when you go up or down, you lose it. There, look. So it's still got the original fault, 0 at 11. And then if you do a reseek, it's okay. And switch the reseek off. Now it's alright after a reseat. No, it's not, look. Going backwards, got a problem. So we haven't fixed anything by doing that. We just cleaned up what I think is maybe some flux. But if I do this now for a minute or so, just leave it like that for a minute, and then do this, you'll find it'll work. That tells me it's probably caps. Yeah, so in the pursuit of whatever cap is causing the issue, I'm going to remove this one. This is not a bipolar. There are 3.3 microfarad caps up there that are all bipolars. Anyway, this one's not, because you can see the stripe there. So ground towards the edge. It's nice these are surface mounted. They're mounted on the top here. Because this is not bipolar, and it's a bit higher capacitance, 4.7, I figure this might be on a supply rail here. Maybe this is the answer. Maybe not. We've just got to well, suck it and see really. So let's get a little bit of flux down there. And I've just tested some of my 4.7s that I've got here. Just looking for one with good ESR. I found one that's like less than an ohm. Most of the other new ones, even though they're decent brands, are like 3 ohms almost of ESR, which, well, doesn't sound very good to me. But this one, like I say, is 0.9 of an ohm. I hope that makes some positive difference. So I'll get to test kit into the drive. It's the easiest thing to test it with because you can do the head calibration test and then just see what it reports. That sounds positive. Often it won't even boot. So, I don't know, let's just see. And sneak around with this. Oh, there we go, 0.11, look. So that didn't fix it. I'll show you. I hate this drive. So let's switch that off. Let's get some contact cleaner into the stepper. Maybe it's not about capacitors. Maybe it's just about the stepper and exercising. God, that's stuck on there. Exercising the stepper is somehow bringing it back to life over a period of time. I don't know. When it reseeks, it is alright. So, I don't bleeding know. And let's get some, because look at that, look at the colour of that. It's like horrible. Let's get some Molicone there, let's just exercise that. Maybe it's just a mechanical issue. You see, the thing is, when I initially looked at this, I might not have done anything other than clean the heads and go, it's just the switches. I suspect that's the case because the gunk that's on there suggests to me that I've never cleaned that off. Seems alright now, look. So maybe it was just needing lubrication. Solid. And I figured an individual track by track seek would be a good test. Interesting thing is there's no ready signal, PC or SCOM drive. Now I know it's not, and this is 4 or 500. Maybe it's a difference on this drive, or maybe there's a fault there on the ready signal. Has that got something to do with the issue? I don't think so. Provided it doesn't fail on a cold test again. I think getting some grease on here has helped because that's going to go, lubricate that whole movement there. But contact cleaner in here might be the issue because maybe one of the commutators is a bit dirty or something, and when it warms up, it just gets a bit better. So maybe having sprayed contact cleaner in that, we resolved it. But when we did that, seek back 10, before there were times when I was going click, 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 and the drive was not making a noise at all. Now it is. I think I should inspect the PCB for any dry joints though on the little controller ICs. No! And one thing that did cross my mind is, well, an intermittent RPM issue, maybe with this thing here. And I can see what looks like a particle of metal or something stuck onto the blooming thing. Like magnetic thing. Can you see here? I don't know, it's like a particle. What I really need to do is, this is like Hall effect sensor, I think. And I would imagine that not being very magnetic. Obviously there's a flex ribbon on top of that, you've got to be careful with that. Let me just crimp this down and see if I can wipe its front. It's like black goo coming off it. You can see it's not coming off anywhere else, but there was that bit. So like, what was that? I don't know, there's nothing coming off it now. Maybe, I don't know, a cap is an issue there, or some resistance or something. Switch the computer back on again. Let's see what it does. Probably won't work at all now. It sounds louder now, but it's worked straight away. It's been in June. It sounds a bit tractory, doesn't it? Like, no, there's some harmonic like thing with the actual RPM. It could just be the noise that the Hall effect sensor makes as it passes the sensor. I might even be able to do that with my phone. If I use the Spectroid app on the phone, I might be able to, I'm going to try that, might be able to work out that it's 300 RPM or something, I don't know, 150 RPM, I don't know what the RPM is on these. Let's try that. Let's just try getting the app up on my phone if I can find it. It's here, isn't it? Or there. Yeah, zoom in you in a bit. Watch where my finger is. There's a little peak there around 100 and something hertz. But then we've got a lot of activity over here. Yeah, nothing really standing out. I think the RPM is probably nearer to 300, and then when you've got a high density drive, I think it's half, isn't it? It's like 150. The drive actually rotates slower as the head does twice as much work in the same physical space on the disk, if you see what I'm trying to say. Obviously the granularity of the signal is, you know, the frequency of it and stuff is much higher in order that it can, you know, write in a smaller area with less power, I think. I think that's how it works in general. Anyway, it seems to be working, so I'm just going to have to do more cold tests. No! So still got the problem, despite exercising it, spraying contact cleaner into the motor. You can see I removed the screw from here, and there's a little plate, let's see if I can show you, with, oh hang on, a little metal bar there. So I'm going to clean all the grease off that little bar obviously goes into the little channel there, so let's get that back in. But before I do that, there's something else I want to do there. I want to just finish cleaning the surface here where the, hang on, the little bar goes, and obviously it's going to align with those things there. But if I just get the, hang on, the fibres off there. So if I now try and get that screw back in, I think I'll try and not move anything here, because obviously it's lined. There we go. I know you can't see what I'm doing. It's like it's not always moving the motor. So I do think that the issue is the actual stepper. So there, it didn't really seek properly. I'll go forward 10 at a time. See, that didn't move. I'm just going to try and push it while I do that. No, it's not moving. Try and pull that way. Move backwards, hang on. So it's weird, isn't it? It's like, why is it jam? I can feel the motor, but the mech is not moving. It's got to be the motor. Let's just do a reseek. Put in an auto reseek. Yeah, I mean, I did just absolutely drench that area with contact cleaner there. So, is it this? You see, getting a bit of contact cleaner there is not quite the same as getting it right in the back somewhere, but you see, this is a sealed unit. Oh! Yeah, so still not really getting anywhere with this. The problem still exists. And I found if I heat this area of the PCB, just near the power connector is sort of just down in this corner down here, then it starts to instantly work. So I'm thinking something around here is either on its last legs, a bad connection, I don't know, a cracked capacitor, something, I don't know. So if I just carefully try and just move this over here, one thing I did notice is, look at this. That's well crooked. Someone's been tinkering on here. Look how glossy this looks around here. Hang on, let's see if we can touch the PCB. I'm not sure if that's a conformal coating or... It looks like it is, or flux or something. Oh, it's not moving around. But like this here, there's the tap. Look at that, it's barely connected. There, but you'd imagine it comes out in the middle. So you know what, maybe that is connected, but that is not straight. And it's obviously very fluxy. So someone's been tinkering. I think I'm going to just get a little bit of flux around that and reflow that. That's a bit better, I guess. And here, because, well, there's a giant blob on top of that thing. That's a bit better, I guess. So place your bets. Do you think it's going to work or not? I'm going to say it's going to work, and we're going to need to cold test it. So let's power on. Hang on, TV's not on. Yeah, I don't think that's booting again. If we get a red screen or something like that, oh no, look, it's not booting now. It's not booting. So let's set the disc in and out. I'll press the switch actually. Yeah, that is not working. No, it's worse now. Somehow it's worse. As a result of heat around that transistor, it's worse. Let's try and heat down here. Let's try the magic switch again. Just do a disc change. It's booting now. It tried to boot and then gave up. But was that as a result of it just been warming up? I don't know. It could be caps still. You can hear it reseeking. Right, let's try heating those 3 caps. Right, I'm going to take that off because I don't think it's working. I need to test it on the meter, work out what it actually is. I'm guessing it's a transistor. What I'm not sure about is what type it is, what its pin out is, if it works or not. I've scoped it, and well, I don't really see any proper activity. I see some activity on this pin here and this one, and then nothing else. So maybe there's a problem elsewhere, but I mean the fact this was crooked and then we reheated it, didn't do very much else, and it just doesn't work at all now. It makes me wonder, is there a bodge underneath this? There we go. That means something shorting. Is the pad damaged where it joins the trace, or is the component actually faulty? We've got an E up there, does that mean that's the emitter? Maybe. It's got to be this transistor though, because well, why else would it now not be working? I know what you're thinking, maybe you cooked it. Well, we only had the temperature 350 and it didn't take long to reheat it. be amazed if that had died. I mean, it could have been that it was on its last legs and us reheating it killed it. But why was it so darned crooked on the board to start with? That makes me think that it had been bodge fixed by someone. So, I don't know. It's all a bit of a strange mystery at the moment. I mean, the real mystery is why it's just stopped working. It's like it's not reading anything at all. It's not doing anything. It doesn't even seek back to sector 0. It spins, the spindle spins, and that's it. I mean, we did heat that as well, didn't we, I think, to get rid of the extra solder. Is that cap gone? I mean, I can test that in a minute anyway. Let's just clean the pants up. God, I fell off the chair then. I'm not really seeing any issue there though, if I point with this thing, you can see there's a good join here. It's not like that was damaged, that's what I want to check. And I'll test connectivity, but that looks like that's joined through to there. This looks like it's joined through to there. And that looks like it's joined through to here. So, don't know, unless one of these wires is bad. As a result of heating this, maybe we finished off a wire. Maybe that's the issue. Maybe we need to plug these with a bit of Commodore. Right, let me get the component testing. I'm going to use the semiconductor analyzer. This came from Nathan and Colin a while back. I bought this off them, but it was, Alison Challis's this. Now, it's going to be incredibly hard to get these 3 things on here without this pinging off. I really don't want to lose this because, well, I don't know what it is. What I'm going to do is get the edge ones like that, there, and then this one I'm going to stick onto the big tab, if I can. There we go, it's just holding in place. Up, I don't want it to drop off. See what it comes back with. Unknown faulty component, look. I think that explains it. The transistor was on its last legs. In some ways, I wish I'd measured it before I reheated it, because just reflowing it seems to have finished it off, doesn't it? We clearly don't have any shorts anywhere. You've got resistance there, like a diode drop. We've got diode drops all over the place there. Let's just turn these around the other way. I know you can't see it. I'll perhaps try and show you that in a minute. Yeah, we've just got like 200 ohms all the way around there. I don't think we have any clues. We've got an E here, which makes me think maybe that's the emitter. Let's just have a look at the other transistors and they look similar. Can we learn anything? Oh, we can. Look, we've got an E. So you know what? We know that that's the emitter, which just leaves base and collector. And look, emitter. Right, so I think we should try an alternative transistor here. Now, my first thought was, are we sure this isn't a MOSFET? Well, you've got an E on the silk screen there. So, it's going to be a transistor rather than a MOSFET. If it was a MOSFET, you'd see, I don't know, GSD, gate source or drain. Unless there was a mistake on the silk screen. So the fact we've got that E there, I think a transistor, and then you've got to then think, well, PNP or NPN, and there are a few other things here. If this was, I don't know, some sort of high power application, a power supply or something, well, you need to be a wee bit more careful about what type of transistor you fit, its characteristics, voltage, current, all the different parameters that relate to, a transistor. There's quite a lot of different characteristics. But with something like this, it's a low power device. You're dealing with lightly, well, I've measured the voltages. We've got 5 volts on the emitter pin when there's no transistor fitted there, and 5 volts on the pin to the far left. The middle pin sort of hovers around 0.3 volts or something. So it's a low voltage application here, low current. It's just going to be some logic on this board. And I have a theory about that. I'm thinking it might be something to do with the ready signal, because we saw on Amiga test kit before, when this drive was sort of working, you know, intermittently, we were getting something about the ready signal. It was saying, it's like, a few times it said drive not ready, drive not ready. I'm not sure whether I captured that at all, but when the drive is completely dead, it says drive not ready. And other times it says ready signal incorrect, is this an SCOM or a PC drive or something along those lines. So it could be related to that. Now, I did some connectivity test. I can't find a direct path to the ready connection, pin 34, I think it is on the IDC connector there. But I'm thinking that's something to do with it. It could be that a CIA was connected to this drive, you know, the Amiga that is, and something was wrong with that CIA, and or the drive was connected the wrong way around at some point, and it killed the ready signal, e.g. this transistor, or the CIA killed the transistor, or vice versa. It may have even killed the CIA on an Amiga. Nevertheless, I'm going to try a transistor. Now, coming back to what I was saying, a general purpose transistor should do. Do we go PNP or NPN? Well, the clue is in the name. I think so anyway. This is my basic understanding of transistors. I could be wrong. There might be examples where this would not fit. But the P and the N stand for positive or negative. So when you've got PNP, you've got positive, negative, positive. And NPN, you've got negative, positive, negative in terms of the, you know, the 3 pins there. And I haven't shown you, but the emitter is 5 volts and the pin to the far left is 5 volts. We've got 2 positive voltages there. So logic is saying to me, I think we need a PNP. We know what the emitter is, we just don't know what the left 2 pins are, but we can kind of educatedly guess that based on the facts. You know, if we look at the pinout of a PNP transistor, and I've got one, a general purpose one, I've looked at the pin out of that, I know where the base and the collector are. It stands to reason that we can just get those pins the right way in respect to the left 2 pins. One of them being having a positive voltage at the moment, 5 volts, and the other one being, well, it's still a positive voltage, but it's very low. And give it a try. If it doesn't work, I can also just flip those 2 pins around. The worst that can happen is maybe the transistor burns up. You could create a secondary fault. This is what I was saying about in higher voltage and higher current applications. Yeah, it could cause you more problems, more damage, etc. Yeah, it's quite possibly some of the bodgiest bodging ever. Yeah, I flipped those 2 legs around so you can see, you know, the end pin here is coming to the middle, and and that's right, the middle pin is bent over and going to the left, and we know that that's the emitter, and it's just bodgily soldered on the very edge. So let's give that a try. Let's move the microscope out of the way. I'll point you down at the drive initially. I'm just going to switch this on and then switch it off and just feel that. Stone cold. Switch it on. Feel that. Stone cold. Well, clearly that is not working, so that doesn't seem to have solved the problem, does it? I don't think. I'm just checking, is it definitely in place here? Ah, one of my legs has come off. Well, there we go. False test there. There's me thinking, is it going to burst into flames? Well, one of the legs wasn't even soldered on. The middle one seems to have just sprung upwards. So let's repeat that same test. I'm going to just switch it on and then off. Feel it. Stone cold. Hold it, switch it on. Ready with the power. It's working. Instantly. That was a cold test overnight. That's the issue. And it sounds a lot more regular. It just sprang into life straight away. Now, when we had this off there, it wasn't working at all. It would not see the disc at all, no matter what I did, no matter what I heated around there, which gave me the confidence, thinking, well, we've taken this off because there was a bit of a bodge, you know, it was like lifted up, wasn't it? It was off the board, and I'll show you the underside of this in a minute. And we've made an educated guess. Let's just switch it off. Let me make sure that's not hot. No, it's stone cold. So let's switch it off. Let's put June in, because that's just going to hit the disc, hit the disc, hit the disc for some, you know, cycles that will go round and round and round. And, you know, just test it over a few minutes. And again, just test the temperature of the transistor here as it starts to load. That's solid though. That is it. That is the issue. We finally resolved the issue with this drive. So yeah, I did, like I say, work my way through a few. I did work my way through a few caps first of all, And I'll show you the ESR of those. They are high ESR. So one or two of the caps did need changing, but ultimately the problem was this transistor, which I think relates to the ready signal. We'll test it again on test kit and see if that issue has disappeared. It should have done, I think, but you can see it is working. I'm highly confident with that. So the only thing to do really is shorten the legs on that transistor and perma-bodge it into place, I think, because we have no clues as to what the model number of the existing transistor was, you know, the one that was originally on there. We don't know what it was. But, well, we can say with a certainty it was a PNP one, because I fitted a PNP. And if that hadn't worked, I could of course just tried an NPN after trying the two different combinations of, you know, wiring. But yeah, it was always in my mind going to be more likely to be PNP based on the voltages I was seeing on the board. Just going to look at one of the other transistors that I've got here, because this is what I've just fitted. Yeah, BC212. So yeah, it's probably not best suited to this, but it's the right type of transistor. It probably came from, or is used in other things like monitors, and it might have even been using the BBC Micro. That might be why I've got a BC212 here. I've got a bag of them. Anyway, I'm very pleased because this Ghetto drive finally is reliable enough for me to use as a test drive. I'll show you how this is reported on here. This is obviously another new one. Look, PNP silicon, and then you've got, yeah, the emitter base collector, current gain 141, test current is 2.5 milliamp, base emitter voltage 0.74, test current in relation to the base. I'm not sure what it says, RIB 4.66 milliamp, leakage current 0, and that's it. So I would say it's pretty much just a general purpose transistor. That you could use that in lots of different applications. But transistors, you know, there are millions of them, and they vary wildly in terms of all of the specs that something like this can't even report, actually. So the point being, you can get away in something like this, you know, low voltage, low current application, audio applications. You could note some differences in quality. You know, if you scope something, there could be subtle differences. In a power supply, some of this high speed, high current, it may just blow. It may cause a fault somewhere else. Certainly if you've got the two of the pins around the wrong way. But it's low risk in this anyway. That's going to be solid. I should put my fingers on this now. It's stone cold. There's not even a degree. Not even 1 degree of temperature. So I think if we just take this off, I'll trim the legs down and we'll bodge it in perma style down there, and that's going to do the job. But this one here, I'll show you this under the microscope again, because, well, there's something interesting on the underside. I'm not sure if it was always like this or whether this is part of a clue as to the fault. If we gain the focus, can you see there? That looks very goldy, doesn't it? It's like, I don't know, something occurred there, a fault, or is that just the underneath of this? Maybe it's flux. Maybe I'm seeing things, because it's very browny there. I think this is flux, look. I think by the time you scratch that off, yeah, look, it's flux. So, as default, this component has the underside like that, and that would make sense with the pad on the board. So, you know what, there's no clues that that's faulty. There we go, that's not too bad. I will, however, just do a short test, just to make sure nothing is short there. I'm sure if I looked around in my collection of transistors, I'd probably have one where the pin order is exactly right. Because they vary in terms of the pin order, and you can... There you go, they're not showing. Yeah, there's no issues there. Switching it on, see what happens. Yay! Insta work. Yeah, there was a time earlier on where I thought, I'm not going to get this driver working with something weird. I was thinking, I wonder if it's like intermittent heads and the heads are warming up, but you see, I don't know, you don't get that kind of thing really. it was always going to be either capacitors. I just realised that solder was trailed right across the board there, and lucky that didn't cause a problem. Yeah, it was always going to be either capacitors or a semiconductor. But I mean, that's the first time I think I've seen a transistor fail on a floppy drive like that. Right, 10 minutes of testing there, solid. Switch it off, touch that transistor, stone cold. It's not even a degree, not even 1 degree in it. It's like, it's cold. It is not even lukewarm. So, that's going to be fine. We can just leave that on there. Put test kit back in. Let's see what's going on with regards to the stability when the reads and things, and that ready signal. Read test, I think, did it. Yeah, that's right now. Because before, it was coming up saying, is this an SCOM drive or a PC drive? Because the ready signal's missing or something, or not right. And then the other thing I noticed is, I forget what it was now, when it was playing up, when it was cold, when it was working, sometimes it would just say drive not detected here. Wouldn't do anything, even though I managed to boot. And then as it warmed up, suddenly it would then start going on saying it's an SCOM or PC drive. That's no longer coming up there. So I think that transistor is something to do with the ready signal. If I go to the head calibration here, when it's cold, or when it was cold, this is what was happening. You'd click there, and it wouldn't do anything. You'd hear no noise at all, like it just couldn't seek. Whereas it's solid, and the noises it provides are very definitive. You're like a definitive seek, and you always get 1111 now. The final thing really is to do a cold test, but I'm sure that's it. I'm sure that's what the issue is. It's solid. Single seek in here. 11, 11, 11. As you can just briefly just see, it says 11, 11, 11. It's got backwards. 11, 11. Yeah, who knew? It was that transistor. Right, so back on Kevinos Cam. It's been on test for 20 minutes now. No problems at all. It's solid. I'm sure that's the issue. And the thing that's just absolutely conclusively proved it to me, I mean, the fact that we measured this and then it goes, there's no component. What is it? No component, don't know what it is. The semiconductor tester, that is, it couldn't work it out. If we just clean around this, just get the flux off there a little bit, and then if I just rotate this somewhat, there are some clues here that weren't so obvious before. If I look at the side of it here, can you see? There, look, this is a crack. See that? And as we rotate around, look at that same point. Can you see there's a crack and a dot? This is why it was slightly bulged off the board. It had got hot as it failed, and sort of pressed itself away. But there's a crack here. It comes down here. You can see it here. You can see it's bulged there. Yeah, so this explains how it moved, because I think what's happened is it's warped, inside. You can sort of see it here. It looks a bit, I don't know, a bit funny. Yeah, and that's why it had sort of lifted itself up a bit. And I think it'd become intermittent because something was just barely making a connection on the inside. When we heated it with hot air, that was it. It gave up the ghost. So, yeah, you can argue I was lucky, really. That would have been quite hard to find. Of course, what you could do, there's only 3 of these on there like that. I could just remove them. If you've got the same model drive and it's not doing anything, or something's not right with it, you could just remove the hot air, test it with the component tester. Now, it's very difficult trying to clip those little leads on here, but I did manage it. I went, from between that one, and this one. Because trying to fit one in the middle there with those little test clips is quite hard. And you could use an adapter. You get like a little SOT23 or whatever the hell it is, this pin out for this. PCB, that's the wires coming off or something. You could do that to test it if it's too difficult to clip the things on. But yeah, and then if you test it in your component tester and it says unidentified component or 2 diodes or something, it's failed. And of course you could test on connectivity on your multimeter, make sure you've not got shorts between the 3 pins there. Yeah, anyway, I bet that's quite a rare failure, but you never know. This particular model drive, those transistors may fail periodically. I don't know. Yeah, that's definitely been baked. Look here as well. Look at that. That doesn't look right, does it? And here. It's got very hot, that, at some point, I think. Because there's like a bulgy thing there, something here. And just ESR testing those 2 caps that I did swap out, I measured in circuit all of the caps. So the other ones that are on there, they were measuring about 2 ohms or something. They were alright though. These ones measured sort of 3 or 4 ohms in circuit. See that? 5.1 ohms, and it gave us 1 beep. So it did have a couple of caps that I've swapped out. One of them I swapped for, I think, the 1 microfarad, not this one. I swapped for a ceramic, just because I had a 1 microfarad ceramic. But I wouldn't do that if it was like, you know, some prestigious Amiga motherboard or some I'd fit an electrolytic or a polymer. You know, polymers, I have no issues with. Polymers are better than electrolytics generally. And you get the same sort of benefits, if not better, smoothing. See, look, that's was 4.1 ohm. So the ceramic I put on there was like 0.2 ohms or something. It's like really low compared to this. So yeah, 2 of the caps did, in my mind, need swapping out. But, you know, they're probably not dissimilar from a working drive. You could test that against 10 of working drives the same and probably find the same thing, that the caps are all measuring like that and they're all alright. The drives work. So it was all about that tiny, awful transistor. Yeah, and I've just remembered these 2 tiny screws that hold the lid on. So we may revisit this in future. I was thinking there are all sorts of different options to deal with the 2 switches. You know, the disk detect and the write protect. I could just create my little PCB with a couple of optical sensors or something there, I don't know. Or just get some other third-party type switches, design my own PCB. I could do that. It's just time, isn't it? So at some point we'll revisit this and we'll do away with the switch and convert it from a Ghetto drive to another drive. And, you know, if you haven't worked it out, in order to simulate a disk change, of course you can just eject it because it stops accessing the disk when you press the eject button. But when you put a new disk in, it still thinks it's got the old disk, and then you've just got to just hold the switch and let go. And then it goes, oh, you've changed the disk, that's it. So the write protect is open circuit, which means you could probably write to any disk, I think. I might be wrong about that. I might really need to bridge between ground and the other switch in order that I can actually write a disk, but I don't plan on writing disks on this, and I'm not that bothered if the disks aren't protected. I hope you found that interesting, potentially useful with these JU-253s. The other drive, well, it didn't need anything doing. It was just cleaned up a little bit. That lid's looking a bit weird there. Can you see it's a bit squashed down? On its side, it's just raised a bit. All we had to do with this one was just straighten out this corner somewhat. So there was nothing really wrong with that, but it has been, as you can see here, repaired. Previously, 2019, that did feature on one of my other videos. I don't know which one, and that's from 1200. This one's obviously from a 500. This was going to go into this 500 plus. You'll see the video on that. There'll be a link top right when that's up, but it can't go in there because we've got this Ghetto switch here. We haven't got the drive switches. So this is going to be a test drive. The other one's going to be a test drive. I'll have to get another one for this 500. You'll see that in the 500 repair. So I do hope you found that interesting. If you'd like to support the channel, please do see the Ko-fi and Patreon links down below. Every single dollar keeps videos like this going, keeps the channel going. I've mentioned so many times that I'm so grateful for the level of support that I get from all the people that support me on YouTube, on Discord, on Ko-fi, on Patreon. I couldn't do this channel without you guys and gals, so sincerely appreciate it. I'll catch you in the next video.